In this video, I will be going over the section 7.1 day 2 notes, and here we are graphing exponential decay functions. And in the previous video, we were actually graphing exponential growth functions. Now, when you approach these on your own, you're going to graph them in the exact same way, but they do look slightly different. In the previous video, exponential growth functions started off low, they had smaller values, and over time those values increased or got larger. And so it started off low, and then over time the graph got higher. But in exponential decay functions, the graph starts off at a higher value, and then over time it gets smaller, so the graph goes down. They both have horizontal asymptotes. They both have the horizontal and vertical shifts that we saw before, but the big change in the growth problems, your B value was greater than 1. Whereas here, your B value for decay is a fraction between 0 and 1. So that's what's going to make this be different for your graph. But other than that, you have all the exact same information from 7.1 day 1, the A, the B, the H, the K value, even the asymptote. All of that is the exact same from before. It's kind of up to you, though, from the last video, if you'd rather focus on an XY table or if you'd rather use the point of interest and then base your answer off that point. That's just a choice you need to make yourself. So I'm going to go ahead and just jump straight into it here with problem number 1. Problem number 1, I have y equals 8 times 1/4 raised to the x power. 8 is the a value, the 1/4 is the b value. There's not a number on the end, so the y value is 0 here. So that means if the y value is 0, that 0 is going to show up for the range as well. So this would be y such that y, and this time it's greater than 0 because the a value is positive. And so once again, you can go the point of interest route. If you want to go with the point of interest route, it's going to start off with 0, and then it's going to be comma 8. 0, comma 8. The reason why it starts off at 0, because the power is just x. And if you take x and set it equal to 0, x is equal to 0. That's where that 0 is coming from. Now, if you take that 0 and plug it into the function, you get back 8, which happens to be the a value here. And that is because there's also a 0 on the end for the asymptote. So with these different zeros that show up in the problem, the point of interest could be found relatively straightforward. But if I was going the XY table route, I would actually have my table start at 0 because that's what I found for this h value. And then I would plug in 0, I might try 1, and I might try 2 as well, and those would give me 3 points on my graph. So if I plug in 0, we know that we're going to get back 8. If I plug in 1, 1/4 to the first power is 1/4. 8 times 1/4 is just 2. And if I plug in 2, 1/4 raised to the second power is 1/16, and 8 over 16 is a half. So at that point, I'm just going to stop because anything I get after this is going to be even smaller than a half. And so 0, comma 8, 1, comma 2, and then 2, comma a half. So I start off high, and then I go down. I get smaller over time, which is the characteristic of exponential decay. Problem number 2, my a value is -2, my b value is 3/4, my asymptote is still at 0. Of course, the domain is any real number, that's always true. My a value, though, is negative, so that means the range y such that y is less than 0. And once again, that 0 comes from the asymptote. So a couple things here. The power is just x. So if you're finding the h value, x is equal to 0. So your point of interest starts at 0. Or, in the same manner, your XY table would start at 0 as well. Then you're going to find kind of the Y value of that. This should be -2. Either you can plug in 0 and see what happens, or you can just take the A value because it doesn't change since the asymptote is 0. And then you'll just pick a few more values to find to graph the problem. So these might be a little bit more tricky just because I have a base of 3/4. So if I plug in 1, 3/4 to the first power is 3/4, and then -2 times 3/4 is, that's -6/4, so -1.5. And if I plug in 2, 3/4 squared is, that's 9/16 times -2. That's not something I really want to graph. So this is going to bring up one change that we didn't see in the previous video. If I kept trying 2 or trying 3 or trying 4 on my XY table, I'm just going to get numbers that probably aren't going to be the best to graph. They're going to be decimals or fractions, and they're going to get really, really close to 0. You'll notice how these are getting closer to 0 in value. But what happens if I would have tested like -1? Right? So if I test -1, that actually takes the reciprocal of this fraction, which more than likely will give me another decimal or fraction, but doesn't always have to be that way. So sometimes when that base is a fraction, negative exponents would actually be a little bit better. And I say that because back in problem number 1, if you use a negative exponent on 1/4, for example, if you use a -1, it actually takes the reciprocal of 1/4 and changes it to 4. And 4 is a nice number to work with. So there are times where you could actually go the other direction on your XY table. You might test negative numbers depending, but I've got these two, so that's probably good enough. There we go. Let's go to the back. So you're going to see the ones on the back change slightly because the asymptote's going to change, and even the H and the K value here. But for number 3, the A value is 6. The B value is 1/3. My asymptote, Y equals 2. The domain, of course, is any real number. The range should be Y such that Y is greater than 2 because the graph is above the x-axis, or above the asymptote, I should say. And so if you're using the point of interest, the 1 is important because if you take the power, x minus 1, and set that equal to 0, that gives you x is equal to 1. That's where that point of interest is coming from. Now, to get the y value, you can either take that 1 and just plug it in and see what happens. That's a really easy way to do it. Or the other way, technically, is to take the a value and add that to the 2 with the asymptote because the graph has been shifted up 2 units. Okay, so this shifts everything up 2 units. So 6 plus 2 would give me 8. So it's kind of up to you if you want to do it that way or not. But more than likely, not a lot of points are going to work here, which is why you might not see XY tables written out for these problems, because sometimes you can't do a whole lot more than maybe the point of interest and the next point around it. But I'm going to start my XY table at 1 because that's what I found for the H value, and we know that's going to give me 8. So then I could try an X value of 2 and just kind of see what happens here. So 2 minus 1 is 1. 1/3 raised to the first power is 1/3. 6 times 1/3 is 2. 2 plus 2 is 4. So that actually worked out to be really nice here. So I'm going to graph the point 1, 8 and 2, 4. But the nice part is whether you're using the point of interest and then just doing some mental math, or using some sort of other method, or if you're using the XY table, they should each involve the same point to begin with. And in this case, that's the point 1, 8. So either way, you should have that that point of interest, that starting point, to be the same. For number 4, I have the a value is actually 1 here, the b value is 1/2, the y value is 3, domain is any real number, the range y such that y is going to be greater than 3 for this problem. And so my point of interest, you're going to take the power, set it equal to 0, solve for x. That's how I'm getting a 2 here. And then the y value should be 4 because you take the a value and you're going to add that 3 from the asymptote. 1 plus 3 would give me 4. So that's going to be 2 comma 4. So then, you could, instead of making an XY table, just kind of test 3 right below it. And so that would be 3.5. Okay, that's number 4. Number 5. We have an a value 4, b value 3/4, y value is the asymptote is y equals -5. So then the range will be y such that y is greater than -5. Now the point of interest has to start with a x value of -1. The y value of the point of interest will be 4 plus the -5. 4 plus -5 is also -1. So -1 is right here. So then you can test 0. All right, so if you want to plug in 0, kind of see what happens there. That would be 3/4 raised to the first. So that's going to be 3, and 3 minus 5 is -2. And for the last one, number 6, the a value is -3. That tells me automatically that the range is going to be y is less than. The b value is 1/4. The asymptote is 0. So I'll go ahead and put that into the range. And then the domain is any real number. Now my point of interest starts with -4 because you take x plus 4 and set it equal to 0. But the y value should just be -3 because you take the a value and add it to the asymptote just being 0. Remember that this graph is going to go down, so -4, -3 is going to be my point of interest. So then I could test -3 as well. -3 plus 4 is 1. This is going to be -3/4. Some quick math there. So to kind of summarize everything that we've talked about here, you can go with an XY table, but the more I've kind of looked at these problems, the way that you could think about it without making a table is to find the point of interest and then find the point that's kind of next to it in terms of like the next point in order. And that would be fine because essentially that's just an XY table without drawing an actual table. But if you're going to use the point of interest, make sure you know how to find that using this h value. And then to find that y value, you take the a value and add the value of the asymptote. But there's your video for today.